12 of your lecture notes, we're going to learn about the graph of the logarithmic function. So let's take a look at the graph of y equals to ln x using your graphing calculator. Okay, so how do you press ln x to see how the graph looks like? Press y equals, okay, and you'll see a ln here on your GC, press ln x. Okay, then you can press graph to see how the graph looks like. This is the general shape of the ln x graph. Okay, but let's go to this second window. Okay, to observe, okay, I'm going to press it as this one I'm going to start it with negative 0.75. I just want you to observe, right? When x starts from negative 0.75 and it increases by every 0.25 value, how do the values of ln x change? Okay, so look at the table. Okay, I just want you to observe these values and you keep scrolling down to see what is so special about the pattern of the logarithmic function. Okay, so observe these values here. Okay, it's on your lecture notes as well. So you'll see that these are the few things that you can notice. Okay, the graph of y equals to ln x, right? It only exists for x more than 0. So you see when x is a negative value, see all these negative values here, you keep getting errors. Okay, it doesn't exist. Even when your x value is 0, the long graph also does not exist. It only exists when your x values are more than 0, when it's positive. Okay? The second thing to note is you'll see that the graph of y equals to ln x passes to the point 1, 0, which means that x-intercept is 1. Okay? At this point, this coordinate here is 1, 0. Okay, the x-intercept. Okay, thirdly, as x increases, your ln x increases. You notice that as your x values increase, right, your ln x values also increase. Okay, that's why your graph is an increasing graph. You see that the general shape is an increasing function. Okay, and finally, okay, the last point here, you can't really tell from sketching the graph on your GC, but the y-axis, which is the vertical axis here, with equation x equals to 0, this line here, is actually an asymptote of the graph of y equals to ln x. Okay, so your GC doesn't show you clearly, but actually how your graph of y equals to ln x looks like is actually taking on this shape, and you must remember to label your vertical asymptote x equals to 0. So your graph of y equals to ln x actually tends towards your vertical axis, your y-axis here. Okay, it will actually keep tending and approaching x equals to 0. Okay. So how do you sketch this graph of y equals to ln fx? There are again 3 steps. Okay, so step number 1, you need to find out what is the equation for your vertical asymptote. How to do that? For any general ln fx graph, right? Look at what's inside your ln. So in this case, fx is inside your ln. To get the vertical asymptote, equate what's inside the ln, the fx, equate it to 0, and whatever you solve for, x equals to whatever number, that is your vertical asymptote. Okay, so that's step 1. So once you find out what's the value, what's the equation for your vertical asymptote, remember to label it on your graph as such. Okay, so that you remind yourself that is going to be a vertical asymptote. When you sketch your graph should tend towards that vertical asymptote. Okay, step number 2, solve for the x-intercept. Okay, so the whole entire equation, whatever it is, the whole equation, equate it to 0 and solve for your x-intercept. Okay. And finally, after you solve for x-intercept, of course, you label that on your axis. And then finally, key it into GC to obtain the shape, and then you can do your sketching. Okay, so don't jump into sketching on your GC straight away when you see the question. Do the necessary steps first. Okay, find out the equation of your vertical asymptote, find out your x-intercepts, then you draw your graph on your GC. Okay, so let's see an example. Sketch the following graphs. The first graph is y equals to ln 2x plus 1. Okay, so step 1, finding the vertical asymptote. Okay, so see what's inside your ln, 2x plus 1. So 2x plus 1 equated to 0. You will get x equals to negative half. And that is the equation of your vertical asymptote. So before you sketch your graph, do the dotted vertical line down, this dotted vertical line down. Okay, this vertical And remember to label it x equals to negative half. Okay, so it must be dotted. It's not a solid line because your graph doesn't touch that vertical asymptote. Okay, so that's step number 1. Step number 2, solving for your x-intercept. Okay, you equate the entire ln equals to 0. Okay, ln 2x plus 1 equals to 0. How do you solve for the x value? Okay, remember that ln is actually base e, so you can bring over the base e, and you'll be e to the power of 0 equals to 2x plus 1, and therefore x is equals to 0 is your x-intercept. Okay, so before you sketch your graph, remember to label this point 0, 0. This point here is your x-intercept. Then, okay, just so happen in this case, your x-intercept and y-intercept will be the same value because when y equals 0, x is also equals to 0. Okay. Then finally, sketch it into your GC to get what is the general shape, and then you can sketch it. Okay, and remember to label your graph. So you see that if you sketch ln 2x plus 1 into your GC, right, you'll get a graph that looks like this. It doesn't look like there's a vertical asymptote. It doesn't give you the complete graph. So remember to extend your graph and tend it towards your asymptote. Okay? That's why it's important not to jump straight into sketching into the GC because it will not give you the actual sketch that you need. Okay? Okay, the second example, ln 2 minus 3x. Okay, so first thing again, step 1, look at what's inside the ln. It is 2 minus 3x. Okay, what's inside the ln is 2 minus 3x. So you equate that to 0, and you'll get x equals to 2/3. So 2 over 3, x equals to 2 over 3, that should be your vertical asymptote. Sketch your dotted vertical line down and label it x equals to 2 over 3. Second step, equate your entire expression, ln 2 minus 3x equals to 0, okay, to get your x-intercept. Again, remember that ln is base e, so you can bring the e over. Okay, so it'll be e to the power of 0. In order to convert it into the exponential form, I do that so that I can solve for my x. So it'll be e to the power of 0 equals to 2 minus 3x, and your x is equals to 1 over 3. Okay, once you solve for that, you know that your x-intercept is 1 over 3, 0. Okay, question clearly wants for, please read the question carefully, okay? They want coordinates. They don't want just the x value. Okay, so they want it in coordinates form. You need to give me 1 over 3, 0. Okay, then finally, sketch the whole thing into your GC to get the shape. You should also solve for the y-intercept. Okay, sorry, I missed that out. So solving for y-intercept is when x equals to 0. So you sub in this value, sub x equals to 0. You'll get y equals to ln 2 minus 3 times 0, and that will give you ln 2. And so before you sketch into your GC, label this point 0, ln 2. Okay, and this is your complete graph. Okay, the last part, notice the relationship between your exponential graph and your logarithmic graph, okay, the ln x and the e to the power of x graph. You see, this is what you just learned, y equals to ln x with a vertical asymptote x equals to 0. And you previously learned the e to the power of x graph looks like this with a horizontal asymptote y equals to 0. Okay, you see that they reflect each other in the line y equals to x. So this line y equals to x acts like a mirror for these two graphs. Okay, they are reflections of each other.